Hello and welcome to the Good Design is Good Business series. Today I have the pleasure of hosting Pete Eeles, who will talk about the process of software architecting and introduce top 10 success secrets for software architects. Pete, if you don't know Pete, he's an Executive IT Architect and Chief Architect for IT in IBM's Worldwide Solution Delivery Organization. Pete helps organizations improve their software development capability, often in conjunction with an architecture-centric initiative such as SOA or strategic reuse, which is in particular Pete's specialty area. Pete is also co-author of The Process of Software Architecting, Building J2EE Applications with the Rational Unified Process, a book that I'm actually holding in my hands right now because it reminded me that that was also a collaboration with one of my old federal DC colleagues, Kelly Houston, and then also Pete has authored Building Business Objects. So it is a wonderful pleasure to have you here, Pete, today, and welcome to our Good Design is Good Business chat today.
Right. Well, welcome everybody. So I'm going to go through a consolidation of a whole bunch of key practices that we've identified, which really deliver successful solutions, particularly from the perspective of the software architect. So I'm going to I'll move the slide on. So the inspiration for this actually comes from quite a few sources. So in my day-to-day job, what I tend to do is help, first of all, organizations architect development environments to improve the way they develop software. But I also happen to quite often work with architecture teams and understand what they do and what processes they follow, what tools they use to be more effective. Now, over the years, we're probably talking about longer than I care to remember, actually, but I've been working with quite a few different organizations in various sectors. One of the things I wanted to do was really understand why certain architects were successful and why certain architects weren't so successful. So what I did was a lot of analysis of existing materials, first of all, some of which you see on slide 2 here. So there are some very well-known publications there. In addition, we've got Grady Booch's Handbook of Software Architecture website. And actually, that website itself is quite interesting because one of the things that Grady is doing is he's trying to, he actually phrases it an archaeological dig of architectures. So he's essentially looking at approximately 100 successful systems and then trying to reverse engineer the architecture. And when I first heard about this, I thought, wouldn't it be good if we could also do the same thing in terms of the practices and processes that these architects had followed? And that really was the origin of this presentation, actually. So I also looked in several well-known books, of course, and along with a colleague of mine, Peter Cripps, we also interviewed quite a few of these architects as well. For example, one of those was Philippe Crookton, who was responsible for architecting the Canadian automated air traffic system. So very experienced architects that we drew on. We've also consolidated that in a book. So the latest book that we've authored is this Process of Software Architecting book, which you see on slide 3. And actually, the agenda, if you like, for this presentation is oriented around almost the chapters of that book, to be frank. But the keys to success are the things that you see on the slide here. And I'm going to go on slide 4. I'm going to go through these. So this really is the agenda for the deck, if you like. So there are some obvious things in here and some less obvious things, actually. So, we are going to talk about things like, how do architects manage risk and change, but also talk about, well, how do architects right-size their involvement for a given project and so on and so on. So of these 10 keys, it's probably fair to say that the first 6 are really foundational concepts, and the last 4 are more to do with the process that they actually follow. So we'll look at how they put some of those concepts into practice when we cover 7, 8, 9, and 10. And one question I sometimes get asked is, why 10 keys? Seems a very random and very a round number. And that's true. So, why isn't it 5 keys? Why isn't it 20? So this really is just the core set consolidated down into something manageable for an hour's presentation. As Roger said, we will break halfway through this to open the call for questions. So moving straight on, there are probably some strange, what may appear to be strange things here, and especially the way I phrase some of these things. So the first one, architects understand end-to-end development. Now, what this is really getting at is that if we think about the role of the architect, then they're essentially the technical lead for a project and work very closely with the project manager, of course. But in terms of the work they do, they clearly need to ensure that the things they create are actually used by other members of the project teams. So they need to understand what developers will be doing, what testers will be doing, and what have you, so that they can interact with them most effectively. And this is one of the key reasons that they need to understand end-to-end development. But actually it goes a little bit deeper than that, because when we start to look at the involvement of the architect in a typical software development process, then we'll see that their influence isn't just confined to what we might call an architecture discipline. And we are going to talk about, well, what's the role of the architect with respect to requirements, for example, and how can they ensure that that's performed more effectively. So we're going to take a look at that shortly. But one thing they do understand is how all of the process actually is intended to fit together. Now, what you see on slide 5 is actually a visualization we created based on the content of something called the Open Unified Process, or OpenUp. And the primary reason for using that as the framework was it does define quite crisply, actually, certain disciplines that are normally quite familiar to practitioners. So the things you see in the rows there, so requirements, architecture, development, test, and project management are these disciplines. Another thing that we're going to touch on actually also is the life cycle. So the horizontal axis is looking at time. So what's the architect's involvement over time? And actually you can start to see an indication of that. So there's some involvement very early on in the project, and then it kind of ramps up as there's a focus placed on driving risk out of the system itself. So we're going to touch on that as well very briefly shortly. Now, what I wanted to do also was just say that when we were looking at what the successful architects do, we were also looking at some processes and methods that had been codified. So we looked at the rational unified process. We've looked at agile processes such as Scrum. Within IBM, we have things like what was called global services method, and that's now based on something called the unified method framework. And I also have the opportunity to work with other clients as well, such as Accenture, Capgemini, and other organizations. So having insight into what they do in trying to formalize some of their processes is actually quite interesting. So what we did, based on that, if I move to slide 6, you'll see a consolidated set of tasks which seem to represent the common themes that seem to be applied in all of these processes. So we've synthesized, if you like, what you see on slide 6. So this isn't something you would find in any given method. It really was just simply trying to highlight the key method elements that you might expect to see in an organization that tries to put a little bit of formalism around what they do. Now, one of the things I wanted to highlight here is that, and it kind of touches on the point I made earlier, is that even though this is the requirements discipline, which we would expect to be owned by business analysts or system analysts, that there are some things here that the architect would definitely need to get involved in. And I'm going to touch on those a little later, but you can see a hint at, defining the system context. So understanding what's inside and outside the system, what integrations with external systems might be required. These are the sort of things that you might see in a system context diagram, for example. And probably the only other thing I wanted to mention is this concept of non-functional requirements. So I think most people who've had any exposure to architecture in a typical project will probably realize that many business analysts especially find it very difficult to articulate non-functional requirements. And yet for certain classes of system, these can be the most important requirements on the project. So we're going to touch a little bit on that as well. And then, of course, we also spent a chunk of time on slide 7 trying to synthesize the key aspects of what an architect does as well. So this is a very simplified version of all the things an architect does, but there are a couple of observations here. First of all, what you can see sort of towards the bottom left of the page is a duality of thinking about the functionality of the system, where there is very much a focus on things like software components, whether they're services or whether they're packages or what have you. But in terms of the structure and behavior, very much of the software elements that provide functionality. And the other aspect is deployment. So what about the infrastructure considerations, for example? So things like nodes and connections and networks are also something we need to think about. And what we found was that successful architects consider these equal, and which is obviously very healthy. And one of the things I'll mention later is it doesn't matter how well you build your software, there are certain qualities that you can't achieve without considering the hardware, the physical implications as equally. So things like performance and reliability are achieved through a combination of well-written software and appropriately sized hardware, which also has certain other characteristics. So that duality is something that we wanted to emphasize as well. The other two things that are on here that may not be familiar to some people, but it is something that, again, we find successful architects emphasized, is first of all, on the far left-hand side, you can see a task called Survey Architecture Assets. So that focus on reuse is another theme that, unsurprisingly, successful architects were certainly conscious of. And the other one I just wanted to mention was on the far right-hand side, document architecture decisions. So when I wrote the book with Pete Cripps, who I see is online actually, so you can help me answer some of the difficult questions you're no doubt going to ask. The interesting thing was that many of the processes we looked at didn't formalize the capturing of the architecture decisions, which was quite surprising actually, because as an architect, one of the things you sometimes have to do is justify your rationale for why something is in the architecture or not in the architecture. So putting some emphasis on that was obviously something we were very keen to do, and that's why we see it in this overview. Other elements there as well, but just for sake of time, we'll crack on. The second aspect was in working with many organisations. I've worked in organisations where everybody seems to be called an architect. But of course, there are different kinds of architects. So we hear of things like a software architect and a hardware architect. You have information architects, enterprise architects, and so on. And so slide 8 was really just trying to put some clarity around the distinction between all of these different domains of architecture. Now you're probably looking at slide 8 and saying, oh, okay, so where's security architecture or performance architecture and things like that? And that's a very valid comment to make actually. But the point here wasn't to be comprehensive and come up with something that doesn't exist in the industry, which is an agreed upon and concise set of definitions for each of these things. It was really just to emphasize actually the difference between software architecture, systems architecture, and enterprise architecture. So let me just quickly go through these things. So as a software architect, which is really the focus of this presentation, I've already inferred that we can't just consider software in isolation of some other things, and especially hardware, because at the end of the day, what we're responsible for creating is a system, and that system doesn't just contain software, and so we need to be aware of these other things. Now, those other things are typically hardware or infrastructure, information, and if you look at the systems engineering definition of a system, it also potentially includes people as well, which is why organization is also listed here. And on our systems engineering, some of our courseware, one of the questions we often ask attendees is, if you're building an aircraft, is the pilot inside or outside the system? And the answer is actually, it depends. Because if that aircraft is in flight and part of a fleet, then clearly the pilot is part of the system, the aircraft system this is. Whereas if it's on the ground and being maintained, then you might have a different perspective on the aircraft, in which case no pilot may be needed. And you end up with some interesting comments like, well, what if it's a remote-controlled aircraft? Is the pilot inside the system or is it outside the system? And you can have some interesting discussions about that. But anyway, the point is, and just to reiterate the comments I made earlier, we can't be successful at building systems if we don't also think about these other elements as well. And the examples of delivering a performant and reliable solution needs us to think about the hardware in conjunction with the software we're building as well. And then finally, the only other one I wanted to mention on the diagram was enterprise architecture. So this is normally a very broad-reaching concept. Within IBM, we actually have a definition which emphasizes three aspects of enterprise architecture. So one of those aspects is certainly the elements of the architecture and how they are related to one another and how you deliver behavior through their interactions. The other two elements are things like transition planning. So how do you move from an as-is enterprise architecture to a to-be architecture? And the third element is governance. So how do we ensure that the organizational technology standards are actually applied consistently across all of the systems that are being constructed as part of the organization and therefore the enterprise? But anyway, so the point here, just to reiterate, is that as a software architect, we need to be conscious of the context in which we architect software, and be conscious of these things that may sit outside of our immediate influence. The third key to success was actually we observed the fact that successful architects managed risk and change in their architectures. Now, to exemplify this, if you like, what I've drawn here is a life cycle which is based on iterative development. And I'm sure many of you are completely aware of what iterative development represents, but it essentially is, especially where, for example, requirements aren't well defined, it's most effective to converge on the requirements by building slices of the solution and evolving our solution over time. And that's something that iterative development really supports as a first-class concept. So what you can see in the three iterations shown on this diagram is the change of emphasis over time. So you can see that in the iteration 1, as it's shown here, there's an emphasis on requirements, a fair amount of architecture, but we still build some code and test it. And the point is, as a result of executing the resulting system, we can then feed back our lessons learned into the next iteration and go through it again. Probably fewer requirements, maybe more emphasis on architecture and so on and so on. But the point here is that the emphasis on architecture changes over time. And I'm going to show the resulting effects of that on risk and change as we move on to the next slide in a second. But this is simply the concept of really the fact that the architecture evolves over time. But the key thing here is that if you do develop a solution iteratively, then the challenge is understanding what you need to architect when. So what are those things that you focus on early on, and what are those things that you might leave until later? And actually, one of the anti-patterns is to focus on the easy things first. So if you're a good architect, one of the things you're looking to do is drive risk out of the system as early as possible. And so normally, we will prioritize the requirements that we're working against and the challenges we're trying to address based on the challenges that the requirements actually imply. So it might be a requirement to be, build something that's highly available, highly scalable. Oh, and by the way, there's some key functionality that needs to be delivered. So they're the sorts of things that we might focus on early on in the project. There's also I think it's yellowy orange box at the bottom right here is also a bit of a soapbox, to be honest, because a lot of there's a lot of discussion clearly about Agile in the software development world these days. And I often get asked, well, how do I view Agile, and what's its relationship to iterative development, and so on and so on. And the soapbox really is characterized by the quotation from Ken Schwaber, who's the essentially invented the Scrum methodology. And the section I've underlined, I think, is the key thing. And what it's essentially saying is that all of those good software engineering practices, including those related to architecture, clearly they're not things that we should throw away. And that sometimes gets forgotten. So you hear a lot of myths about Agile. So, you don't do architecture, and you don't document architectures. Somehow an architecture emerges from the code. And I think anyone who's been on an Agile project will realize, well, actually, there is architecture done. It's just that we don't do a huge amount of it. So this notion of big upfront design is something that we don't advocate. But the point is that all of those good software engineering practices still apply. And that's very much a view that I certainly agree with. I personally think that Agile is more of an emphasis on the people-related aspects and things like collaboration, interaction between IT and the business, and things like that, rather than trying to reinvent the good software engineering practices that we've always applied.
Yeah, I think that especially rings true because, and this is managing risk is probably one of the biggest challenges for anybody on a project. Because oftentimes you don't want to address the risk, you want to put it off, earlier in your project, because it could impact the project severely. And I think that, as I've heard someone say, the best project managers and architects address that risk head on to drive it out of the project if it's possible, if at all possible.
Absolutely. And in fact, on that note, I'll just move to the next slide. The effect of driving risk out can be visualized in several ways. So one is, of course, you would expect to see the level of risk diminish over time. But another way of thinking about that on slide 10 is that the top part of the slide here is an improvement in the stability of the architecture. So if you do put a focus on driving out risk and focusing on the really hard things first, then the stability of the architecture will be achieved, such that you can then, really get more developers maybe aligned with building out the rest of the system once that stability is there. Another impact, of course, is, what's the emphasis in terms of resources or architecture resources, especially during the life of a project. And really, the bottom part of slide 10 is again, just replaying what I said earlier about the focus of architecture changing over time. So there's just another formalism there. Okay, we'll take a break in just a few slides. I just wanted to cover off a few other key points. So these foundational concepts, some of them, when you read the slide title, they sound so obvious. And yet when I work with certain clients, they believe they're doing some of these things, but they're not really. And one of these things is, well, how do you actually communicate in architecture? Because there's a lot of emphasis on things like, well, let's create some models and let's sketch up a few things. Let's draw a few diagrams. Let's bring out our favorite UML modeling tool and start to draw a few things. And actually, all of that is starting from the wrong point. Because the right point is to start with what's on the right-hand side of this on slide 11, which is who are your stakeholders? What are their concerns? And how do you group those stakeholders together so that you have groups of related concerns? So we've got two stakeholder groups here who are interested in this architecture. So we might have developers, users. Of course, there would be other groups as well. There may be an infrastructure team, there may be a sponsor, maybe a customer, and so on and so on. But for the purposes of describing how I personally think about architecture descriptions, then I think this simplified view is more than sufficient. So the thing is to start by understanding who your stakeholders are, and then almost moving from right to left. Think about, well, how do they want to be communicated with? And that's actually quite important because even though I'm an advocate of things like UML for applied in the right situation, UML diagrams aren't always the right thing to communicate the architecture in terms of certain stakeholder groups. So would you, the common question asked is, would you show a UML diagram to a business sponsor? Would they actually understand what the notation meant? So the point here is understand your stakeholders, and then the second step is understand how they want to be communicated with. And then, and only then, can you figure out what things you need to create, which is where we see this functional model and deployment model described. Only then can you create the elements or the actual artifacts that you would create in order to support that communication. So the point here is very much start from the right and then work your way to the left. And then when you're on an actual project delivering a solution, then you work from left to right and say, well, okay, so we know who the stakeholders are, we know how to communicate with them, we now know what artifacts we need to create. Now let's create them and package them up accordingly and then communicate the architecture back to those stakeholders in things like review sessions or what have you. So it sounds very obvious statement to make, but it's surprising how many organizations I've seen, and they just start on the left. They just start creating models without really thinking about who they're trying to communicate those things to. There are some additional concepts. Let me just check. Yeah, so I didn't put an additional slide in. There are some additional concepts that are very, very valuable when it does come to communicating architectures. So there are formalized definitions of things like models and views and something called viewpoints. Views are a concept that will allow you to take different perspectives of the architecture, again, for different kinds of audience. So there is an IEEE standard, which is also now an ISO standard for that. And if anybody wants any information around that, then feel free to contact me. Just two more things I wanted to touch on before we open it up for questions. So the fifth item, so architects reuse assets. Again, the slide title is so simplistic, you think, yeah, so what? Of course they do. But what we're showing on slide 12 is a taxonomy, if you like, of the different kinds of reusable assets, different types of reusable asset at the disposal of the architect. So when they're architecting a solution, what things might they draw upon? And again, Pete Cripps and I did a survey of all of the different asset types that we were encountering. And one of the things we wanted to do is be quite crisp about the difference between, say, an architectural style versus an architectural mechanism versus a reference architecture and so on. And then we laid it out in terms of the meta model that you see on slide 12. There are some very significant assets, of course, so things like a reference architecture that you see at the top. Fundamentally, a reference architecture is an architecture, and therefore you would expect to see a significant part of the architecture of your system predefined, were you to base it on a reference architecture. All the other elements are broadly classified as either a development time asset and a runtime asset, and that division doesn't hold up to scrutiny. But it does help us explain sometimes the different types of asset that we see here. And broadly speaking, that abstraction is simply saying there are certain types of asset that you normally think about in terms of, when you're developing a solution, this is when I would typically apply that kind of reusable asset. So if I'm creating an architecture, I would probably introduce patterns into my models and what have you. Whereas there are other kinds of asset that I tend to think of in terms of, their runtime, they're executable and they're applied, when the software executes. So things like a component or a package application. Now, the reason it doesn't hold up to scrutiny is actually every single one of the types has both a development time element to it and a runtime element to it. So, for example, if I apply a pattern at development time, then I may see it in an architectural model, but I could also potentially see it in terms of, the execution of the software. If it conforms to that pattern, then it also has a runtime representation. And vice versa is true. So if I have a packaged application that is applied at runtime as part of my system, then I may have a representation of that packaged app at development time as well, which maybe shows some of the key interfaces and maybe some of the custom modules that I've built into that packaged app. So that's why that particular abstraction doesn't hold up to scrutiny. Probably the only other thing I would mention is that we deliberately included existing application as one of the reusable asset types, because there is a tendency within experienced architects, we found, that for them to ignore an existing landscape. And I think it was Oscar Wilde who said, "A cynic is a man that knows the cost of everything and the value of nothing." And that, to me, really characterises certain individuals' views of, are existing applications reusable assets, or are they just, legacy that we're trying to get rid of all the time? And of course, they're probably some of the more strategic assets that we have at our disposal. So, so that's why we included that one there. So I'll draw breath after this next slide. But another aspect of defining, when architects follow an approach to being successful, and Pete and I codified that in the process of software architecting book. But it's also important that different systems require different emphasis on architecture. And so one of the things you need to do is understand, well, how much emphasis do we apply, and how do we vary the practices we have at our disposal, so that we don't over-engineer things or under-engineer things, in fact. And on slide 13, I first saw Philippe Crookton present this, and he said the guy in the top left, that's Grady Booch's dog. The house in the top centre is Grady's old house. Bottom left is Grady's new house, and bottom right is Grady's new house with the servants' quarters, which caused a lot of merriment when it was mentioned. But clearly, the point is that there is a big difference between architecting a doghouse from a skyscraper to a city, and building software is no different. And an articulation of that in more concrete terms on slide 14 is this very imprecise characterization of a small project versus a large project. So one of the things that you might define as part of the implementation of techniques, practices, methods, and so on to these projects. If we just look at something like the roles, then you might have a single person who actually plays the role of all of the different characterizations of architects that you might have defined in the process. So the application architect is the infrastructure architect, and they're also the data architect as well. Whereas on a large project, you may have additional architect roles, and you may have an individual or several individuals actually fulfilling each of those roles. So understanding the application of the practices and any standards, any methods that have been defined needs to be done with, in the knowledge that you have a particular emphasis on architecting that you need to achieve. And that applies to other aspects of any method elements that you might consider as well. So, how are you going to execute the method? So how do you perform tasks? What's the nature of the things you're creating? So if you have these work products or artifacts you're producing, then what level of formality might you need to put into each of those, and levels of completeness and things like that. So I think, Roger, you kindly put a question slide in.
Yes, I thought that'd be a good way for us to
Thank you, sir.
take a breather here for a moment. Great stuff so far. One of our attendees actually wants to use some of the concepts that you're already talking about, and he mentioned that to me privately in the chat window. So appreciate your interaction there, everyone in the chat window. Just as a reminder, today's call is being recorded, and it is a mix of not just IBMers, but a mix of IBMers, customers, and business partners. So we welcome you all to this call. I am going to open up the lines now for questions. Well, all the lines are open now, so.
Okay. Well, there is a question there.
If we do get some line noise, I'll go ahead and mute the lines. But did anyone have a question before we carry on?
So there is one there in the chat window, actually, Roger. So,
okay.
So the question is, do we follow a different strategy for mobile apps? Which is a good question. I think at the level we're talking about, I believe the answer has to be no, because I think at the level we're talking about in terms of focusing on risk, understanding the end-to-end development process, reusing assets, and things like this are all applicable clearly for mobile apps. I suppose one of the observations is a lot of mobile applications, depending on the device itself, may introduce more hardware considerations than others. So if you're actually building a mobile phone, for example, in which case there are some additional practices that you might apply around things like systems engineering. But I do believe that everything that I've described so far is equally applicable in terms of how you document architectures and what have you.
I couldn't agree more. I'm working actually also alongside a lot of the mobile app dev initiatives that we're working on, and we'll be hosting Lee Williamson in the future as well in the same forum. But you know, most applications that we see out there are applications that are really extending the enterprise. They're not the Angry Birds applications, so to speak, but they're bringing whatever corporate or organizational value to the mobile device. And you know, this means that you're probably tapping into an existing architecture. So at a minimum, architecture reuse is probably one of the key things in that mobile strategy. But you know, that's, of course, just one small part of a bigger picture that Pete's alluding to here. So.
Yeah, absolutely. In fact, I'm working at a bank, at a very large bank in the UK at the moment, and I'm having the opportunity to apply some of these concepts within their 600-man architecture team. So that's quite a few architects. And
boy, that sounds like a topic for a future chat. I would love to hear more about that at a future time. So
once we've delivered some success, I agree.
Yeah.
But the point I was going to make was that, you know, some of the concepts here are being applied there, and they have many different, even though they're a bank, they still have many different kinds of initiatives. So they, of course, they have custom development projects, but they also have things like, you know, maintenance projects and security projects and data-intensive projects, infrastructure projects, packaged application development, integration projects, and so on and so on. And what we're finding is that the fundamental building blocks and best practice apply to all of those things. And it really goes back to the point I've just finished making, actually, which is you know, you need to think about how you apply those things, you know, these keys to success for a given situation, and certainly right-sizing the process for those different kinds of initiatives is an obvious thing that you would need to do. But I do believe that at the level we're talking at, all these things are applicable. Excellent.
Well, Pete, why don't we go ahead and carry forward, 6 down, 4 to go on your.
Yep, let's finish up. So we're already on to key to success number 7. So, and I hinted at this earlier actually, which is architects influence the requirements. So if in your organisation, you know, you have a method defined, it would probably say that, you know, the definition of requirements is the responsibility of a business analyst or a system analyst. And actually, I believe that's true. They are responsible, but one of the supporting roles may well be an architect. And the reason that, if I go tell you what's on slide 16, the reason I like it is actually the emphasis on non-functional requirements. Now, one of the things about non-functional requirements, it's not a term I particularly like, because a non-functional, you know, it almost tells you what these things aren't. They're not functional requirements. And so my point is, well, okay, so what are they then? So one definition of a non-functional requirement is it's something that represents either a quality or a constraint. So what Pete and I did here when we wrote the book was actually think about, well, what kinds of qualities and what kinds of constraints do we typically deal with? So at the top, yes, we certainly have functional requirements, but in terms of, you know, which are very much driven by stakeholder input and the functionality that they're looking for from a given system. But if I kind of go clockwise around, as an architect, one of the things we need to do is balance these competing forces and make trade-offs. So the things we might need to accommodate are things like business constraints. So things like, you know, the system needs to be available within a given window of opportunity, so there's an influence on schedule. We may only have certain skills available to us through the resources that are available, and we may need to actually flex the architecture to accommodate that. In terms of technical constraints, we may, we may have a constraint that the system may need to be distributed across different locations, and as software architects, we may not have the influence to say, well, actually, let's consolidate everything into one location, because that's not the real world. In terms of platforms, one of the things we might be constrained by, again, is the fact that we may be told, essentially, that we need to deliver the system on, for example, the Java EE platform or .NET or Z-Series or what have you. And again, that would be a technical constraint. The other side of non-functional requirements is in terms of qualities. And again, you can divide these into either runtime or I've just tripped over my own comment here because I've called them non-runtime qualities. That should really say development qualities. And the sort of development qualities that we might need to build in are things like the maintainability of the system, especially if it's long-lived, as opposed to a tactical solution. Portability, so if we know that we're going to need to maybe move platform at some point in the future, then that may be something that we need to build in. And in terms of runtime qualities, the more familiar qualities, actually, things like scalability, performance, availability, and so on, are the sorts of things that we have there. I don't think, I just wanted to move on one slide just to see what we've got there. Yeah, so one of the things that Roger's mentioned in the chat window is there are taxonomies of non-functional requirements especially, and there is an acronym called FERPS, which, as Roger's put here, stands for functionality, usability, reliability, performance, and supportability. And that's a taxonomy that comes from a chap called Robert Grady in Hewlett-Packard. And that can be very useful for the architect because you can almost use that as a checklist of things you need to think about for a given project. There's also an ISO standard which also has another taxonomy, so it's ISO 9126, I believe, which also has a list of non-functional requirements that you might need to consider. But the point is, as I said, when you start to look at some of these non-functional requirements, it really is the architect that is probably most familiar with these and can provide the best input to the stakeholders in terms of their impact. So moving on, again, architects derive solutions from business needs. No kidding. So again, the slide title doesn't tell the story really. The point is that there are different approaches in getting from requirements to solution. And again, Pete and I did a survey of what some of these things were, and there are several different approaches out there. 3 are shown on slide 17. The one I was most familiar with until about probably 7 or 8 years ago was the rational unified process. And that focuses very much on deriving a solution by looking at the functional requirements and the architecturally significant non-functional requirements, and thinking about, well, what are the elements inside the system that would allow us to address those requirements, both functional and non-functional, but actually with an emphasis on the functional requirements, it would have to be said. And it was quite interesting to contrast that with, say, the first example up here, which is a technique called attribute-driven design, or ADD, from the Software Engineering Institute at Carnegie Mellon University, which is actually very widely used in industry. And to really give an indication of what this thing helps you achieve, if I were to say to you that we need to build a solution that needs to scale to support 6,000 concurrent users, it's going to have a UI presented through browsers and mobile devices. There'll be persistence stored in a relational database, and we need 4 nines availability. Now, based on all of that information, we could almost start to sketch out some possible solutions. We might introduce things like, we've probably got a firewall in there, we've got a web server, we might have application servers that are clustered, and yet, I haven't told you what this thing actually does. All I've given you is a load of non-functional requirements, actually, essentially qualities that the system needs to exhibit. And so the underlined item there is that these quality attributes, as they're known, drive the architecture. And Pete and I found that very interesting, in fact. So one of the things we tried to do in the book was bring these two together and say, when you're building a solution, of course you need to look at all of the requirements, functional and non-functional, but you really deliver a successful architecture by thinking of these two areas as peers when you start to think about the elements of our architecture and the solution moving forward. So, the next few slides just give an example, actually, of the approach that I mentioned in the Rational Unified Process. So I'll just go through this very quickly, just to save some time. Essentially, what you've got at the bottom of slide 18 is a use case. It's actually a context diagram for a single use case that shows an actor on the left, a tour booker, which is either a customer or a sales clerk. So this is for a tour booking application, and some external systems that are interacted with as a result of that use case executing. Now, even looking at that simple diagram, which contains a functional requirement, essentially, we can start to think about, well, if we had a blank sheet of paper, what are the sorts of things that we're going to need in terms of the architecture? Now, one of the techniques, and especially this thing from the Rational Unified Process, which is called robustness analysis, as it happens, suggests that you would create a boundary component between the interface between any actor and the system. You would have a control component for the use case, which controls the execution of that use case when it executes in the solution. And you may identify some entity components as well, which hold any persistent information that you may derive from the description of the use case. And just by looking at the description and the simple guidance just given there, you can derive the components that are shown on slide 19. And it's a very simple technique to give you a first cut architecture, albeit at a logical level. So there's no technology here. And of course, there's another discussion as to, well, how much logical architecture do you actually need to do? Because, you know, we can't code stuff based on this. What we code stuff off is based on things like, if it's a Java EE platform, we have things like Enterprise Java Beans and what have you. But we'll come to that shortly. You know, the point here is that doing logical architecture is often a good stepping stone in getting from requirements to a solution, and that is really how it should be viewed. Very much so. It is simply a stepping stone. Of course, slide 19 is a structural diagram, and you're probably wondering where some of the operations on each of those elements have come from. So what we tend to do at the same time as identifying these key architectural building blocks, if you like, is, as shown on slide 20, is understand the interactions between them. And here we see a sequence, UML sequence diagram showing the interactions of some of these things in realizing this book tile use case. So those operations came about as a result of us placing responsibilities essentially on the various elements that you see in the various lifelines here. So, for example, the very first interaction is from the tour booker actor to the tour booker boundary component, and is essentially asking that boundary component to get all of the tours available, and therefore that boundary component has the responsibility of being able to do that, and that's why we see that operation on that particular element. So let's just move on. Roger, you couldn't move on one slide, could you? My network seems to have done something interesting. Thank you, sir.
Let me just take presenting control back, and I will. Oh, it looks like we may already be there. Is that what you're looking for? The outline deployment?
As long as that's the slide after the previous one. Yeah, sorry. If you go back one, please, Roger.
Yeah.
Because the comment I was going to make was it really goes back to the earlier point, which is that we can't only consider the functional elements in a solution, so components and interfaces, but we also need to think about the infrastructure or deployment elements as well. So on slide 21, this is a UML deployment diagram showing a single location, a central office, and some of the nodes that are actually going to reside in there. I'm not going to go into detail as to how we identified these things, because that would take quite some time. So what we then need to do is connect these two worlds together, the functional model, essentially, and the deployment model, as you see on slide 21. So if you move to the next slide, please, Roger. So on slide 22, the way we achieve that is through a concept, in this example anyway, of a deployment unit. So you can see how we're now linking the functional elements to the deployment elements via the deployment units. And you know, you don't necessarily need to do this for everything in the architecture. It really is just to understand where how you're going to place some of the functional elements onto the deployment elements in order to achieve collectively the requirements that are being defined. So this is a particular perspective of the architecture that might allow you to additional insight into the solution you're architecting. Okay, next slide please, Roger. And then almost finally, so clearly the next thing we would do as an architect is think about, well, what are the technology implications of the solution we're building? So if we decide, for example, that we are using the Java EE platform, which an articulation of which is shown in the top right of slide 23, then we might say, well, if we're providing a browser-based interface or certainly an HTML-based interface, then there are concepts within the Java EE platform for things like those elements served up by a web server, so things like Java server pages and servlets, and for an application server there's this concept of enterprise Java beans, and there's a whole bunch of technology to allow you to connect to back-end systems, whether they're relational databases or something else. Now the point we wanted to make here is that actually when you get down to this level, a very effective way of minimizing the amount of architecture description you need to do is simply to apply some patterns to the logical architecture. So, for example, we saw earlier that there was this notion of a control component that controls the execution of a use case. And one of the things that we could do is simply apply a Java EE pattern to that and say that every control component is realized in terms of a session facade, EJB. Now, session facade is actually a well-known Java EE pattern, and a simple articulation of that is shown in the bottom left there. Apologies if you don't understand the Java EE platform, but the point is that you don't need to model everything. And that actually is one of the common pitfalls, is that we've seen many architects that do just that. And rather than abstract things out into patterns that get applied, and there's an architecture decision documented that says every controller will be implemented using the session facade pattern, is they actually describe every single session facade in their solution, which is fine, but you just need to be aware that there are potentially simpler ways of describing your architectures. And it's sometimes easier, in fact, to describe your architectures in terms of the patterns that are accommodated rather than trawling through every single element of your solution. So big fan of patterns and reuse in general. And last slide, please, Roger. I think it's the last slide. It's certainly the last key to success. The other thing we observed is that in the context of a software development project, essentially, which is represented by this red bounding box here, it's extremely valuable to understand the broader context. And we did mention enterprise architecture earlier, and that's just one example of something that you might need to be conscious of as a software architect. So in many organizations, both Pete and I have worked with, there is a concept of a design authority that's responsible for ensuring the application of the enterprise architecture on each project. So it essentially is a governance body. Other things you might need to be aware of, some key dependencies, infrastructure provider. So you may need to be reliant on someone else providing and provisioning the hardware on which you're going to deploy your software. So again, that key dependency is something to manage clearly. And the final thing we're showing here, clearly there are other stakeholders, but these seem to be some of the key ones, this concept of application maintenance provider. So as an architect, one of the things that you might need to acknowledge is that the team that's going to be maintaining the system after it's been created initially may not actually have the same skills as the team that created it. And so you do need to accommodate that in the architecture work you do to maybe simplify some of the things that you may have produced in order to, as I said, accommodate the skills available in the application maintenance provider, which may be another organization, of course. Phew. So I think if you move on, Roger, there's probably just a summary slide, but yeah, that was a quick tour of the key themes, I think, certainly from the book that I wrote with Pete Cripps, as well as the things that we saw in practice, to be honest. And it is something, this deck is something I go through when I first talk to an architecture team, just to really stimulate a conversation about, what are the key concerns that a particular organisation might have, and then we take it from there.
Excellent. Well, the lines are open for questions for Pete. This is a wonderful opportunity to connect with an executive IT architect at IBM and ask some questions. If you do have a little trouble hearing you, then press *6 on your phone to make sure you're not muted.
Yeah, this is Bill Hunt. I have a question. Can you hear me okay?
Hey, Bill.
Hey, I have seen really a significant rise in companies that are implementing agile development with rapid iterations, like 2-week iterations and sprints and backlog management and stand-ups and the whole dance with agile development. And I've also seen a rise in business process management projects and business rule projects, which lend themselves to almost an order of magnitude increase in frequency of changes. And so with this whole increase in agile development, what have you seen evolve and change, and what aspects of software architecture do you think are perhaps becoming more heavily used or more less used? And you did mention a little bit about agile earlier, but it seems like we're at an interesting point in accelerating that movement and actual use of agile development.
Absolutely. Hi, Bill, and that's a great question. So I think one thing that we've learned from Agile is that we do need to be mean and lean. And I've seen, in fact, I've worked on teams where there is an architecture element, so Agile projects where there is an architecture element. So one of the things we sometimes do is introduce an architecture owner into the project team. And I suppose the thing you've touched on, Bill, is actually the key thing, and it's actually one of the reasons that the Rational team certainly is putting an emphasis on providing development tools that do support the architect, where things are highly collaborative, and we do have these rapid iteration cycles. So there's something called Rational Software Architect Design Manager that provides the linkage into some of our other collaborative lifecycle management tools. I think the key thing actually is that the amount of change that needs to be accommodated based on a particular architecture is normally quite small when you're doing rapid iterations, because even though they are very rapid, then the amount of change is almost by definition quite small. But what we do need is technology to allow us to continue to adopt best practice in terms of good software architecture practices, but also the technology and the tools to allow us to update those things that we do still achieve a lot of value from. So having lightweight modeling tools is certainly one of those things that can help with that, as long as they're plugged into the broader life cycle of how you manage change, being able to configuration manage your models and things like that. So for me, one of the key things is simply about being more efficient.
I couldn't agree more, Pete. The software supply chain only needs to be that much faster to deliver. And spreadsheets and documents just aren't enough anymore to let teams scale up their operation of delivery of software. And I look back actually at a project we worked on in 1999 with, it was actually a hardware/systems manufacturer that actually went on 3-week sprints. Now, this was, of course, before really the concepts of Agile really became entrenched in the industry, and IBM embraced it. But they designed a little in the 3 weeks. They used, a use case drove the architectural change, forward generated the code. The developer, filled in the blanks of the code execution in the next 3-week iteration, and then while that coding was happening, they were already working on the next set of use cases and architecture. And that rapid-fire delivery approach, staggered and overlapping delivery approach, worked really well for them.
So one follow-on comment or question about that in the Agile space, one of the interesting dynamics of this realization of Agile development is that, and a big part of the reason I think it's taken off is our customers, both the business stakeholders and the IT stakeholders, are seeing that Agile works not just technically but financially, that we're able to realize return on investment sooner and in more frequent increments. And so does that, what's your opinion on that creating an opportunity for the architect to be, financially speaking, a more influential stakeholder from a practitioner and customer client point of view as well as a software sales point of view?
I think that's a really good comment again. One of my soapboxes is that when I talk to organizations about Agile, the first question I ask is, well, what are you actually trying to do? Because there's a big difference between what they may perceive as Agile and delivering agility. Because to me, a key enabler for agility isn't just method or process, so it's not just about using Scrum or what have you, but it's about architecting your solutions in the right way. So one of the reasons that it's important is that, when you are doing early drops of, potentially a solution that actually get to real users. So you may have intended, this thing to be a 9-month project, but after 4 months you've actually got something that can deliver value. To me, that is enabled by architecture, and the architect is, the key role that would be able to provide the right amount of guidance as to what makes a sensible subset of a solution to be deployed. Probably the caveat there, though, to be honest, is that we talked earlier about driving risk out of the solution. So there is a balance to be struck between delivering functionality that can be deployed to end users, but also minimizing risk by actually focusing not on functionality, but focusing on those most challenging requirements that may need to be delivered for, when this thing's complete in 9 months, then it will need to be highly available, and making sure that you've addressed those things early on as well.
Yep. So the main thing that that we seem to struggle with from a client implementation standpoint and from a software sales standpoint is having someone that owns the business case, and it would be great if we had a if everyone knew exactly what the business value work products were. Oh yeah, of course we're going to use that spreadsheet approach and that financial analysis model to tie with traceability of architecture focus to the value the business is going to receive. So that's where I'm a little bit weak.
I think it's fair to say we're still learning, Bill. But to me, I
probably,
think
probably a good conversation for you guys. I don't mean to derail this now. I know we're over time, so I do want to respect those who might have other questions. But that might be a good conversation for you all to have, just on your own. Maybe a little bit.
Thank you very much.
No, I appreciate it, Bill, and be happy to talk to you more after today's call. Let me give an opportunity for other people to ask questions, but if not, you guys can extend that conversation. So, any other questions for Pete? Going once? Twice? Well, again, this call has been recorded. It will be posted along with the video to the landing page. It's listed in the chat window. That also has a download of the slides, if you just want to look at the slides again, as well as a survey. It's just a brief 5-question survey just to let us know how you're doing, and if you like the topic and want to see some more related topics, give us some ideas. We'll be happy to have you back on topics that you all are interested in. So with that, and Bill, if you wanted to stay on and continue to talk while we're here together with Pete, provided Pete has additional time as well, you guys can carry on the conversation. Otherwise, I wish all the attendees a wonderful rest of your day. Thank you for attending. So Pete and Bill, if you guys wanted to carry on, please do.
Thank you.
Thanks. I'll wait for you to stop the recording.
Okay. Let me do that.